Hello friends, welcome to Ekdanth Environment Educations. How are you all? Fine. Hope your preparation is going on a very higher pace, at a higher pace. Okay, and these all lectures, whatever we are going to take, will be very much helpful for your examinations, upcoming examinations like UGC GATE, then the GPSC Assistant Engineer, BPSC Assistant Engineer, MPPSC Assistant Engineer, and also the CPCB Scientist B examinations. Okay, so these all lectures will be very much helpful for your examinations, and whatever the lectures that we are going to take over here will be the exactly as per your syllabus we are designing these lectures. Okay, so this will be very much helpful to you all. So we have already started with our preparations for all these examinations with our first lecture from water supply engineering, and today we are going to see the part 2 of the water supply engineering. Okay, so those students who are new to this channel, please like it, subscribe the channel to get the latest notification of the lectures uploaded on the Ekdanth environment educations. Okay, because it will not going to cost much more to subscribe or like the video. Okay, so it will just help me and motivate me to make the new videos so that I can put my extra efforts to bring you the materials whatever I have. Okay, so these all will be very much helpful to you in your upcoming examinations. Okay, so let's start the lectures without wasting much more time. So in the last lecture, as we have seen, the topics like water demands, factors affecting the water demand and the per capita, then the factors affecting the losses and the waste. Okay, different types of variations in the demand and the assessment of normal variations. Okay, so the last topic was the assessment in the normal variations. So as we know that based on assessment there are different formulas like maximum daily demand, maximum weekly demand, maximum monthly demand, average monthly demand, right? So in that there comes one topic that is called as what? Peak factor. Okay, peak factor plays a major important role while calculating the water demand. Okay, so today we are going to see the topics like peak factor, coincident draft, the effect of different variations like seasonal variation, monthly variation, hourly variation, daily variations on the design capacities of different components of the water supply scheme. Okay, while designing the different components of the water supply scheme, its capacity, while designing the capacities, we need to know the effect of different variations. Okay, that which component works on which type of variations, whether the component like the distribution pipe or the pumping station works on the maximum daily demand or the maximum hourly demand. So these all will be going to cover in the point number 3. Okay, so the fourth one is your design period and the last will be your population forecasting methods. Okay, so let's start the chapter. So first topic is your peak factor. Okay, this is the most important topic from exam point of view. Okay, so if you are really very much aware of the examinations, then I must say that you should note down this topic or this table, because many of the examination ask this question that if the population is above 50,000 or about 2 lakh, what will be the peak factor value in as per the GUI manual on water supply scheme? Okay, so as per the Government of India manual on water supply scheme, the following table gives the peak factor value on different range of population. Okay, so this may come in a 1 mark question. Okay, so let's see that up to the population of 50,000, the peak factor value is 3. And if the population is 50,000 to 2 lakh, then peak factor value is 2.5. So as the population increases, the peak factor value decreases. Okay, so you can clearly see over here that above 2 lakh population the peak factor value is 2. Okay, and for rural area water supply scheme the peak factor value is considered as 0.3.0. Okay, so this peak factor value is very much important from exam point of view. Mark it star. Okay, next, coincident draft. Again, there are many questions in exams also that what is coincident draft. Four options will be given, that maximum daily demand, B maximum daily demand plus maximum sorry, option B will be maximum daily demand plus fire demand, option C will be the maximum hourly demand, and the last will be none of the above. So the answer will be what? Maximum daily demand and fire demand. Okay, so these type of questions come related to the coincident draft, and many of you will might get confused that what is coincident draft. Coincident draft is nothing but coincident draft. So the word coincident itself suggests that coincident means all of sudden the demand, the draft that is generated coincidentally. Okay, so we have to consider that factor also while designing the water supply scheme. Okay, so for general community purpose, the total draft is taken as the sum of maximum daily demand and fire demand, or the maximum hourly demand. Okay, whichever will be the maximum out of two. First one is MDD plus fire demand, or the maximum hourly demand. Out of both these, whichever will be the maximum, that will be considered as our coincident draft. Okay, so I have make the statement in red mark that most important. Okay, the maximum daily demand when added to the fire demand for working out the total draft. What is total draft? That is summation of all the demands. Okay, while working out on the total demand, water demand, when the maximum daily demand is added with the fire demand, it gives us what? The coincident draft. Okay, so again it is, make it star, it's an important for exam point of view. Next, the effect of variation on the design capacities of different components of the water supply scheme. Okay, in the last lecture we have seen that there are various types of variations like seasonal variations, then comes your monthly, hourly, daily variations. Okay, and these variations have different effects on the per capita demand. Okay, so while designing the capacities of different components of the water supply scheme, the effects of variations are very much important. Okay, so let's see what variations we should consider while designing the different components of the water supply scheme one by one. Okay, so the very first one is your source of supply. Okay, so your source of supply, for your source of supply, the variation we will consider will be the maximum daily demand or the average daily demand. Okay, the second one is your pipe main. Pipe mains mean your a pipe which will conveys your water from the source to your service reservoir. Okay, so that will be your pipe main. So that will also be designed as per the variation called maximum daily demand. Okay, maximum of the components of the water supply scheme are designed as per the maximum daily demand. Few of them are designed based on the maximum hourly demand, or we can say that the maximum hourly draft. Okay, likewise, the third one is your distribution system. The distribution system designed as per the variation maximum hourly draft or the maximum daily draft and the fire draft, whichever is more. Okay, that means the distribution system works on coincident draft. Okay, remember this point. Next, filter and the other units. Okay, that works on the maximum daily demand. The fifth one is your reservoir, service reservoir, from where it goes to the distribution pipelines. Okay, so your service reservoir also designed to take care the hourly fluctuation, fire demand, emergency reserves, and all of them. Okay, and the last one is your pumps. So pumps will work as per the variation maximum daily demand. Okay, next, what is design period? Okay, this is also very much important, that which component of the water supply has uh, what that is like a question like what will be the design period of say for example pumping station, or what will be the design period of the intake works. Okay, so you should know that what will be the design period of all these components of the water supply scheme. Okay, so that comes as a 1 mark question. Okay, very much important from exam point of view also. So see, these things are not important, the statements are not important, just the statement that what is design period is important, and what is the value of that component, what is the design period of that component is important for exam point of view. Okay, so remember that thing. Just to know what is design period, we have to read all these things. Okay, so a water supply scheme includes the huge and the costly structures which cannot be modified easily and conveniently in the short period. Obviously, अगर हम कोई भी वाटर सप्लाई स्कीम को डिज़ाइन कर रहे हैं, कंस्ट्रक्ट कर रहे हैं, तो उसमें बहुत सारे पैसे जाएंगे अपने, ठीक है। उसके साथ साथ हमारा टाइम भी बहुत जाने वाला है। अगर हमने बिना कुछ सोचे समझे जो भी कम्युनिटी का पॉपुलेशन है, उस पॉपुलेशन को हमने कैलकुलेट नहीं किया प्रॉपरली, और हमने जस्ट प्रेजेंट पॉपुलेशन के हिसाब से कंस्ट्रक्ट कर लिया, तो फिर फ्यूचर में जो भी डिमांड रेज होगी उसको हम फुलफिल नहीं कर पाएंगे, राइट। तो जो हमने जो भी स्ट्रक्चर बनाया होगा वो स्ट्रक्चर क्या करेगा, फ्यूचर पॉपुलेशन को सेटिस्फाई नहीं कर पाएगा। तो उस वजह से क्या होगा कि आपको फिर इन बिटवीन उस स्ट्रक्चर को मॉडिफाई करना होगा, है ना। और मॉडिफाई करना छोटे समय में बहुत ही इम्पॉसिबल है ना। कर सकते हैं, लेकिन क्या होगा फिर कुछ समय के लिए आपको पूरा का पूरा सिस्टम बंद रखना पड़ेगा, तो वो हम नहीं कर सकते। ओके, सो इसके लिए क्या करते हैं कि हम एक डिज़ाइन पीरियड कंसीडर करते हैं किसी भी वाटर सप्लाई स्कीम के कंपोनेंट्स को डिज़ाइन करने के लिए। ओके, सो कि से फॉर एग्जांपल हमने कुछ वाटर इंटेक को डिज़ाइन किया। अब वाटर इंटेक कितने साल तक सर्विस प्रोवाइड करेगा उस कम्युनिटी को, वो हमको कैलकुलेट करना है ना। उसकी कुछ लाइफ स्पैन होती है कि ये अगर हमने कुछ आरसीसी से कंस्ट्रक्ट किया से फॉर एग्जांपल, तो आरसीसी का लाइफ 15 ईयर्स, 20 ईयर्स, 30 ईयर्स, इसके बाद वो क्या होगा, उसकी क्वालिटी डिटोरिएट हो जाएगी, तो वो सर्विस देना बंद कर देगा, है ना। या कुछ हम कोई से फॉर एग्जांपल कास्ट आयरन का पाइप ले लेते हैं डिस्ट्रीब्यूशन पाइप में, है ना। तो उसमें भी क्या होगा, कुछ समय के बाद वो करोड हो जाएगा, उसके अंदर पंचर्स इतने आने लग जाएंगे, लीकेज इतने हो जाएंगे कि वो बराबर सर्विस नहीं दे पाएगा, उसका मेंटेनेंस बहुत ज़्यादा आना शुरू हो जाएगा, है ना। मीन्स उसका डिज़ाइन पीरियड ख़त्म हो गया, उसका लाइफ स्पैन ख़त्म हो गया उस मटेरियल का। तो हमें कोई भी कंपोनेंट या कोई भी स्ट्रक्चर डिज़ाइन करना है, तो उसके लिए हमें एक डिज़ाइन पीरियड फिक्स करना पड़ता है कि इस मटेरियल का लाइफ स्पैन इतना होता है। सो इस मटेरियल से बना हुआ जो भी स्ट्रक्चर होगा उसका डिज़ाइन पीरियड या उसका लाइफ स्पैन इतना है, वो इतने साल तक सर्विस दे सकता है, ठीक है। तो उसको हम बोलते हैं डिज़ाइन पीरियड। ओके, सो in order to avoid the future complication of the expansion, the components are purposely made larger so as to satisfy community needs for the reasonable number of years। बराबर है, जो मैंने आपको समझाया वही बोल रहे हैं यहाँ पर भी, है ना। This future period for which a provision is made in designing the capacity of various components of water supply scheme is known as what, design period। Okay, अगर हम किसी फ्यूचर पीरियड को ध्यान में रखते हुए हम उस कंपोनेंट का डिज़ाइन करते हैं, उसकी कैपेसिटी को हम प्रेजेंट पॉपुलेशन के हिसाब से ना बनाकर हम उसके फ्यूचर पॉपुलेशन को ध्यान में रखते हुए उसकी कैपेसिटी को बढ़ाते हैं, तो उस चीज़ को हम क्या बोलते हैं, उस फ्यूचर पीरियड को क्या बोलते हैं, हम डिज़ाइन पीरियड बोलते हैं। ओके, मतलब आपको समझ पड़ गया होगा कि डिज़ाइन पीरियड क्या होता है, ठीक है ना। आप स्टेटमेंट पे ना जाइए, जस्ट आप उस कॉन्सेप्ट को समझ लीजिए कि डिज़ाइन पीरियड क्या होता है। ओके, डिज़ाइन पीरियड कोई भी मटेरियल का बहुत ही छोटा नहीं रख सकते या बहुत ज़्यादा लंबा भी नहीं रख सकते, ठीक है ना। सो एक एवरेज में लेके हम चलते हैं कि इतने साल के बाद वो मान लो कि उसको चेंज करना ही पड़ेगा, है ना। ऐसा भी हो सकता है कि से फॉर एग्जांपल हमने डिज़ाइन पीरियड किसी किसी कंपोनेंट का हमने 15 ईयर्स रख दिया, लेकिन वो मटेरियल अच्छा हो गया, उसका मेंटेनेंस टाइमली होता रहा, तो वो 15 की जगह 20 ईयर्स भी वर्क कर सकता है ना। तो हम एक सेफ़र साइड मान के चलते हैं कि उसका डिज़ाइन पीरियड इतना रहता है, ठीक है ना। सो डैट क्या हो सकता है कि हम पे ज़्यादा बर्डन, उस यूनिट पे ज़्यादा बर्डन ना आ जाए, और एक मेंटेनेंस क्या ज़्यादा ना हो, और वो चीज़ इकोनॉमिकल बने हमारे लिए। इसके लिए हम उसका एक टाइम स्पेन उस हिसाब से हम सिलेक्ट करते हैं, ठीक है। So let's see what are the different design period for the different components of the water scheme. Again, this is very much important from the exam point of view. Okay, they may ask the question that what is the design period of the intact works. So it is 30 years. Okay, what will be the design period for the distribution system? Again, it's 30 years. Okay, so this is very much important from the exam point of view, that they may ask the design period of different items, or different what called the components of the water supply scheme. So as per the Government of India manual on the water supply scheme or the water supply project, they have recommended the following design period. Okay, so you can see the storage of dams 50 years, intact works 30 years, then comes the pumping house 30 years, pumping electric motors and the pumps 15 years, water treatment units 15 years, pipe connection 30 years, raw water connecting units, conveying units 30 years, service reservoir 15 years, and the distribution system 30 years. Okay, so this is very much important from exam point of view, so you may remember this design period. Okay, very much important from exam point of view. So make a start to this table also. Okay friends, so moving ahead, population forecasting. Yes, so if you are going to design any water supply scheme for any community or any society, you need to know the population, present population, and the future population. Okay, you have to calculate it by using different formulas given by the scientist, and different. Okay, so there are different methods adopted to estimate the future population by the engineers. Okay, so let's see. The first one is your arithmetic increase method, geometric increase method. Second one, the third one is your incremental increase method. Fourth one, the decreasing rate of growth method, simple graphical method, comparative graphical method. Okay, seventh is your master plan or the zoning method, ratio and apportionment method. Okay, and the last one is your logistic curve method. Okay, very much important from exam point of view. Also in gate they may ask the question that calculate the population for the decades, like the table will be given, the last value will be of, say for example, 2000, and they will ask the population of 2020 or 2030. So accordingly you have to calculate the future population using these formulas. Okay, this is very much important in other exams also, like UGC and others. They ask the questions that what is the type of a ideal population curve, what is the shape of the ideal population curve. So the curve shape is S. Okay, so they ask such questions in exams also. Okay, so this is very much important from exam point of view in all the examinations. So try to mark all these things. Okay, and hope you like today's lecture. Similarly, we will coming with the next lecture on the detail of this topic, population forecasting. The detailed lecture on population forecasting will be our next lecture. Okay friends, so please like it, subscribe the channel, and share with your friends for the next lectures also, so that they can also participate in these lectures. Okay friends, so thank you so much for watching your Ekdanth environment educations. Bye bye.